Hello, Chris. Thanks for joining me on Turtlecast.
Thank
I
you.
wanted to bring you on, one, because I nerd out a little bit about space, and there's many others. And you wrote a phenomenal book, not because it speaks about space exploration, but you're reasonable.
Thank you.
And I think that's the most attractive thing. It's the most attractive thing for me when I read Spacefarers is that there's reasonable steps that get us to a certain point and why we shouldn't rush certain other things. But
Yeah.
you've compounded this on the history of the space race itself and how it's gone from a very war-driven economic machine to a very privatized now, pseudo-economic focus machine of human achievement. Like, what's the next step for us?
Yes.
And so I think that the bridges you made between history, how it's developed, and where it's brought us now are phenomenal. And then from that, the feasibility, when we do go to choose to live on the moon, right? Or live on Mars, or hang out above the clouds on Venus, whatever it might be. Right? I hope I'm getting this right.
That's you got
Right?
it right.
That's
Whatever turns your boat.
the options are there. The question is, how do we get there? And
Right.
so where I want to start is with you. Chris, what was the draw for you? How is it that you even get to the focus of space and your own personal history, right? Your own background, personally and professionally, that brought you to that point to like, I got to put a book together and I got to talk about the reasonable trajectory for how we launch this thing off. No pun intended.
Okay. Well, it's kind of a funny answer because I wasn't that kind of space enthusiast. I mean, I worked at NASA for 10 years and it was a great experience. And I had a rather envious title there. I was the senior writer for the structure and evolution of the universe. Okay. The pay didn't match that, but nonetheless, that was my title, senior writer for the structure and evolution of the universe. Big concepts, Big Bang, black holes, gravitational waves. That was my beat when I was working at NASA. So then Harvard came to me, Harvard University Press. They were starting a book series. And they said, well, listen, you can have any subject you want in the universe. And you think that would be pretty broad. But they were all taken. Big Bang, someone was writing it. Gravitational waves, someone was writing it. So I came up with this idea of colonizing space, which was honestly down on my list because I didn't see it as very practical. If you talk to astrophysicists, they will see that this space colonization is so complicated and so tedious and difficult to do that it's not even worth discussing. We're not at that point. So that wasn't never on my radar screen. But then I started reading it and I had these incredible arches. I read Robert Zubrin, Case for Mars, like, yeah, we can do this. And then I read some, things from astrophysicists. No, we're not going to do this. No, and then it goes up and down depending on who you're reading. And I thought to myself exactly what you're saying. Well, let's approach this rationally. There has to be not necessarily a middle ground, but there has to be a practical way to approach this. And I'm a skeptic by nature. So, one of my early books was Bad Medicine, in which I looked about, misconceptions in medicine and things that just don't quite work. So I was very skeptical about these claims that we could live on these places. And I found that, a lot of the people's stance was, well, it doesn't break laws of physics, therefore we can do it. But what was never addressed was the why we would do this. We got these things like it's in our DNA to explore. Well, that gets you out there, but it doesn't keep you there. When I gave these presentations, I like to talk about Mount Everest.
George Mallory.
Exactly. Why did we climb it? Because it's there. We're not living on Mount Everest. We're not setting up, we're not, there's no schools up there. No one's working up there because it's not very practical. And that's what you have to think about with the moon and Mars. Yeah, we'll get there, but what would actually keep us there? What would be the economic and emotional motivations? Just like you and me and our families coming to the United States, there were economic and emotional motivations that brought us here, not simply because someone invented a boat. And likewise, what would cause these migrations? That's what I wanted to investigate. And what would keep you there? There has to be some economics in place and philosophy in place in addition to the basic engineering.
Let's touch on that. There's three reasons you stated that somebody would want to take this sort of risky approach, one is for reasons of deity or religious reasons, right?
Yeah.
That's numero uno. The second one is war. Okay, if China says we're going to be on Mars or the moon with a base by this time, and you had this exact line, I think, we're going to be on there a year earlier in the US.
Yeah.
And then the third one was economic reasons, right?
Yes.
So maybe we find some sort of material efficiency by going to mine an asteroid that has a massive amount of titanium, right? Much more than we would have from like a supply here on Earth. But just getting to that specific point really is a tough place to get to. So the most fundamentally, the simplest one for a political sense for people to get behind is pretty much the war-based one. And that's how I kind of read it. I mean, it worked in the 50s, did it not?
Yeah, sure.
We had the ice race.
Yeah, we're not on the moon.
No, we're not.
It got us to the moon, but it didn't keep us on the moon because it sets you up as just a race. I won.
Yeah.
That's it. I won. It didn't set you up for permanence in any way.
Right. And when I think about this, Chris, and tell me if I'm wrong, when you go to make these sort of explorations, there's a lot of technology that also has to be built that gets you to that specific place, right?
Right.
So, and I'll use a basic metaphor. George Mallory was climbing Everest in breeches, all right? I don't care how much beeswax you put on your breeches, it's really not going to block the ice and the wind and all that other stuff that's going to, give you frostbite and kill you.
Right.
But we've developed over time companies like North Face that allow us to make these things more feasible, right?
Yes.
Or during the Manhattan Project, that sort of technology eventually down the road leads us to things like CAT scans.
Yeah.
So getting there isn't really the big thing. It's all the technology developed to that point that actually gets us to that point. So I feel like there's such a focus on the fact that we have to have a habitable moon base. This will be a solve for us. It's great to get here. We want to do it. It's a human achievement. But really, it's actually more beneficial for what goes on our planet alone. Because if I go up, say, to Mars, I'm going to need phenomenal engineering for closed systems where we do great amounts of recycling, right? And, hydro cropping and all that other stuff for these, our greenhouses to grow these plants, but do it efficiently and recycle the stuff. These things will help us learn in very strenuous environments how we can teach us in our own environment where we're currently lacking that sort of technology and insight. Am I right about that?
You nailed it. On Mars, you can't open the window. You can't. You can't open the window. There's no airing things out. It all has to be 100% recycled. We haven't succeeded in that.
No, and frankly, I find this interesting. Earth is a relatively closed system.
Yeah.
And we do a poor job of maintaining it.
Right.
And then people want to jump from this planet and then create these artificial closed systems and think that we're going to do a phenomenal job at it.
Mm-hmm.
But you start to fill those gaps on the in-between. And I would love if you could explain what sort of, in the simplest format, the logical process you see it for our future and the timeline for how we get from point A, Earth, to point B, the moon. Just the moon as the first example.
Okay, sure. Lot of baby stepping. And I think what we're seeing right now, it's hard to connect this to the moon, but with Bezos and Richard Branson going into space, quote unquote, I think that's a fine first step because it's starting to cultivate interest and creating a new market for very wealthy people to go straight up and straight down. I mean, there's really nothing really significant about that. They're not in orbit, as you might know. They're just going up 50 to 60 miles, which is just breaking into space and then coming back down. But there's so much interest in this. And if they continue to lower the price for those tickets, you're going to have a new kind of industry of space tourism. And I think that's a fine step to get more people into this business and to make the rocket launches that much more efficient. And that's what Elon Musk has been brilliant at, and the efficiency of the rocket launch and bringing the cost of payload down from $20,000 a kilo down to about $2,000 a kilo. So he's done, that's a factor of 10. He's done tremendous work in that, making things cheaper and getting more people interested in it. So that was a great first step. And I think a next good step is to have people in low Earth orbit, like the International Space Station, which if you read in the book, I'm not a fan of whatsoever. But there are other clever ideas, like what's done by Bigelow Aerospace, if they can remain open through this pandemic. But they were going to launch these inflatable, expandable units. And instead of the price tag of billions of dollars, which is what the International Space Station is, over 100 billion, for a few tens of millions of dollars, he could launch these up and people could visit them on various rockets run by other companies, Blue Origin, and maybe not Virgin Galactic, but SpaceX. So is that business to business happening in space, which is always great to lower the cost, that kind of competition. And then you could have ordinary, very wealthy people living in low Earth orbit for a week or a month. Again, building up the excitement and learning what is possible in these closed environments. And then, we could go back to the moon right now if we put enough money to it. But
sure.
I think the logical way back to the moon was not this still on the books 2024 deadline set by the Trump administration. No one ever believed that, and eventually it's going to just fade away. But not only was it too rushed to get back to the moon with people, it didn't serve any long-term purpose. It brought you back to the space race and just getting people there just to dance around and plant a flag. But if we can be systematic about this and start building the infrastructure now in concurrently as we're getting more people into low Earth orbit and set up robotic devices that can build the infrastructure, some inflatable domes on the moon. Now that we have inflatable domes in space, get them on the moon and get some robots to cover them over with the regolith for the radiation protection, and set this up in the next 10 years so that we can take a rocket and get ready to live there indefinitely.
This is sort of my focus here. Rockets, they're great, they're fun, but they're really not efficient.
No.
It's like I have a rowboat and I have all these big heavy rocks in it, and I have to throw the rock out as fast as I can to then hopefully generate enough momentum to move this boat forward that already has rocks on it. So I don't have like an infinite capacity of that energy. And so to fly there, you're gonna have to go to probably the moon first and then make another jump over to Mars or wherever else you're going. It takes a huge body of time. So you have this massive increase in risk because of essentially the energy problem that we currently have. And so when I read your book, we have a massively growing population. That's obvious. There's only so much arable land we currently have on Earth, and we waste a lot of our food. And by the time we build an energy system on Earth, the population's already outgrown it because it takes 3 to 7 years to even build that energy infrastructure into a country or that area. So we're in this like sort of constant deficit. And space would be the solve for us only if we can fix, in my mind, the energy issue here on Earth. Fusion's a great proponent for it, but also what's the fact that of propulsion systems actually moving large amounts of mass efficiently? That's a hard thing to do. It's like cattle in a field. How do I get? I'm a farmer with 1,000 acres. How do I efficiently move it? A 2,000-pound bull from all the way on this side of the ranch to the other side of the ranch. It's so much energy, so much time. I have to physically move them, but they also have to graze and go to the bathroom and create waste before I get there. So when I think about ourselves, I think there's been a lack of focus on the actual energy systems themselves. I think that people are reappropriating technologies like rocketry. Yes, I love the vision of being on other planets, but then you also have energy deficits when you get to those planets. What happens when a severe storm comes by and rips off the solar panels, right? It's not like we're going to be launching micronuclear reactors that we use in some of our satellites. It's like you have to do something that's actually feasible when you get there. But the thing is, you're going to have to test it here on Earth first. So I feel like we're almost getting ahead of ourselves. How do you feel about that?
Yeah, a lot of what you say is true. There's going to be short term solutions and then long term solutions. You know, with the energy problem, say on Mars, I think we can get by, uh, for a year mission. But if we actually want to be there permanently in some way, whether it's science bases or some people living there all the time, we would have to come up with a new kind of energy source, because you certainly can't rely on solar.
You
But
can't.
I do think people are thinking about this, because what's nice about Mars is that everything we need to live is there, but in forms we don't necessarily want. So the whole
Yeah.
atmosphere is carbon dioxide, but you can take that, add some hydrogen, and convert that to methane. And that
Yeah.
could be a major fuel, natural gas. That could be a predominant fuel for moving things on Mars. Um, on the moon, you can, I think, rely on solar all the time, because there are no dust clouds like there are on Mars. And so in the South Pole
Yeah.
region or the North Pole region, there's these areas of near constant sunlight, because the planet isn't tilted. So all year round, it's getting this light from the sun coming from the top and the bottom. And you could set up solar panels there and have constant energy. It's only when you move to the equator that you're going to have light only half a month, 2 weeks of light, 2 weeks of darkness. Then you're going to have to come up with some battery solutions. I don't know if it's directly addressing your question, but even on the moon, there's uranium. You could have nuclear power plants on the moon. That would be very difficult to set up, but the raw material is there to go nuclear on the moon. And you don't have to worry about the waste, because
Yeah.
the moon is one giant pit.
And that's also an interesting question. What do you do with waste? How do you determine? Okay, so I have a growing population. I have energy issues, but I still have to grow food. But then I also have to set up the aspects of the infrastructure itself to live, right? Before I can even start growing the food, I'm going to have many, many missions going there, dropping things off so that we have enough raw material resources and,
Mm-hmm.
whatever sort of stored energy to build these things together. I know
Mm-hmm.
that even during the ice race we had here on Earth, setting up nuclear reactors in the Arctic or Antarctic was a very difficult task, right?
Mm.
Especially some of the earlier mobile ones that we had that the US set up. And that took a lot of manpower. But when you describe the situations of people living in those environments currently right now doing research studies, whether it be, Russia or, I think you said New Zealand or Iceland, they have skeleton crews.
Yeah.
And sometimes they don't get fresh food, right? So it's like, I know what it is trying to run a company, trying to keep people happy and do these other things. I could not imagine what it's like grabbing a group of individuals to say that you're going to go to an extremely high risk environment. There's going to be massive energy deficits. There's no guarantees we're going to get you these resources. Oh, but we need you to build this stuff.
Yeah.
So how is it that Chris, how would you incentivize somebody? How would you do you have to hire a bunch of psychopaths to do the job? Like, what is it? Like, who's the right sort of human character that fits that bill?
Oh, they're out there apparently, and I think Antarctica, like you described, is the perfect test area. I've met some of these guys that go down there. They're totally into the adventure. I mean, they're a bit crazy, and they're willing to take this on. Phil Sadler comes to mind. He lives out in Arizona now, but he's the one who decided to build the first greenhouses down there, first at McMurdo Station, because he's going through the winter, and it's like, I need some lettuce, I need some crunchy food or something. So, he took it upon himself to start building these kind of things on their own. I mean, they're wacky engineer types, and it's just in their blood to have that sense of adventure. And he brought that concept down to the South Pole as well, as building greenhouses down there to grow year round under lights. So I do think those kind of mavericks are out there to set things up, to MacGyver the situation until civilization follows later. I think that's always been the case with human development. When you look at the United States, course, you had the Native Americans, but the first people who came over weren't necessarily the Pilgrims, but you had these traders, the people getting pelts and such from deep into Canada and the northern part of North America. And then, bringing out, these guys were purely into adventure, living on their own. And these people still exist today.
Yeah, no, I think you're right about that. Actually, you are absolutely right about that. But, it's to consider one aspect of it. Okay, say we've built our system. Say we're on the moon, we're on Mars, or we're floating around in a low Earth orbit in a balloon. What happens when a foreign biological substance shows up?
Wait, can I go back to the previous point, though? I just want to say one more thing. It came to mind.
Yeah, absolutely. Go for it.
And with Antarctica, I think that's a good example of how long things take and how that can apply to the moon. Because we got to the Antarctica around 1900, but it took about 50 years before the technology developed for us to actually be there permanently. And then another 50 years until you started adding these kind of luxuries like energy that works all the time and crunchy food in greenhouses. So that's a long process. Obviously, it didn't happen overnight. And when people complain about how we're not back on the moon, it's been 50 years. And coincidentally, Antarctica took that long. We go there. 50 years later, the technology develops that maybe we can go back and forth a little easily now and start setting up the infrastructure that allows us to live there with some element of comfort. So I wanted to add that it's a step-by-step process. It takes time, unfortunately.
I think what you're speaking about, Chris, and we'll jump into my other comment about the biological factors in a second, but things have a natural evolution, and everybody wants to jump past the steps. But the steps are actually required. If we don't build the right fundamental basis, we're taking on risks that don't need to be there. And that's why I think you said Nixon, he's like, oh, the oxygen tank blows up. Some people, we're not doing this ever again, right? Totally emotional response. I'm not doing it. We pushed it too hard. But I think that if we skip the fundamentals, even solving them here on our own planet, it's going to be very difficult for us to solve them in very high risk environments outside of this current closed system we're on.
Absolutely.
Like say, for instance, how we handle epidemics, plagues, things of that nature. They spread very quickly. We have high populations, but it's not the fact that the population's high. It's that people live so close together and we're interconnected. So say I send you up there and some sort of biological contaminant comes into one of our stations. The rate at which that spreads, it could shut down the whole operation immediately.
Yeah.
And then how are we going to know? Because, those planets are spinning. So there's going to be a point where information cuts off from the radio signal and people could be essentially dead for a bit. And it's just floating around and everything. And at NASA, everything's great. Everything's looking good. We haven't heard anything back. You know what I mean?
Yeah. No news is good news.
So it's like, right. And so how is it that, how do you look at the biological factors of this, right? Because I know that there are certain contaminants that do float around in space, certain fungi, certain microbiomes. What is it that poses as an actual threat? Is there any data that can, support or say that, maybe we should focus on fixing that here first before going out?
Right. Well, there has been, unintentional experiments on the International Space Station. People have brought up colds and viruses, and everyone gets the cold. There's no way to avoid that. And now COVID comes down, and you have intense quarantining and all these tests to make sure no one going to the International Space Station is bringing anything contagious. That was a hard. I mean, it was an obvious lesson to learn, but it was a hard lesson to learn because people had been getting sick. And then other contaminations can happen with the food supply you're sending. Of course, there could be E. coli on there. So they have to be incredibly careful with what the biologics that they're sending to these places. I think that's the main risk, what we carry there. And people who are visiting are going to have to go through a quarantine. And of course, going to Mars, it takes so long. That is your quarantine. Anything that if anyone was sick, I think it would have manifested in the 9 months to get there. or even 9 weeks if we ever get it down to that point. Going to the moon, it's a little trickier. It's only a couple days away. So I think people would have to be quarantined before and after going to the moon with the risk of, to prevent the risk. I don't think there's other space risks in terms of organics in space that we would have to worry about on the moon or Mars, because space is so sterilizing. I think it's very hard for anything harmful to be coming from space, coming from Earth naturally and landing on Mars or wherever.
Yeah, and I brought that up because you probably worked at NASA at the same time my uncle did. His name is John Rummel. He was the Interplanetary Protection Officer. So he dealt with exobiology.
Mm-hmm.
So anything that either came into Earth or was leaving Earth's atmosphere, he had to be there to actually scan it, see it, what's going on, what possible contaminants are on it, or what you'd be bringing with you into space itself.
Oh, interesting. Uh-huh.
And so that's why, I focus on that, because a lot of things can go wrong in the unseen world, right?
Mm-hmm.
No one's walking around with a microscope 24/7. Their focus is, I got to build a base.
Yeah.
And when I look at those things, I see, there are all these difficult or challenges that really need to be thought through that the general public typically doesn't look at. And there's so much data. There's just so many catalysts in this specific system to make it work that we need to make sure they're all represented appropriately.
Yeah.
And there was one that you touched on, which I thought was cool. And that's what happens to human biology, especially in low gravity environments, right?
Yes.
Your eyes start to fail, the shape of your platelets change, things of that nature. So what happens in terms of long-term effects, if you could explain this for people, when I'm in a place that has a much different gravity, specifically on my organ structure, skeletal structure, and my cellular biology itself?
Mm-hmm. Well, yeah, that's just it. And the short answer is, we don't know. When we think about gravity's effect on the body, we only have 2 data points. We know what it's like on Earth, and we know what it's like at the ISS. That's 0 and 1. And that's all we know.
Yeah.
And how do these lines connect? How do these 2 points connect? Is it a straight line, where if you have a little more gravity, you got a little better health? Or maybe you need like a lot of gravity before you can have full health. Or maybe you just need a little bit, like in mining, just a little bit of gravity helps things settle. You don't need a lot, just a little bit.
Yeah.
0 gravity, it's impossible. As long as things are eventually falling, that's okay. Maybe human health is like that. So maybe the 16, 17% of gravity on the moon is enough for us to develop naturally. We have absolutely no idea. That's a big open-ended question.
That's a tough one, right?
Yeah.
And it's the thing that humanity always tries to escape.
Right.
It's our own gravity. It's gravity of our situations. It's the gravity of the atmosphere. Think about atoms, for instance.
Yeah.
Right? You have angular momentum. It's like, is it enough for the electron to leave its shell and go somewhere else? Everything's always trying to essentially escape this gravity within itself. But how things develop in different states of gravity is what I find abundantly interesting and probably one of the more difficult solves. And I think that a more articulated or poignant focus on gravity and the energy systems around it may be beneficial to us in the long run, rather than just shooting a rocket up there and saying everything's going to be all good, but I don't know if my organ's going to end up, internally crushing me over time, or I'm going to have a lack of a structure and my bones become brittle. You see?
Right. Yeah. And I think that's how blinded we are about Mars in particular. People talking about just assuming we could live on Mars. And that's the overarching question of gravity, of the 37%, 38% gravity on Mars.
Yeah.
If you can't gestate, if you can't raise a child, that's the end of colonization. There's nothing else you can do. That's the end of it. You can only go there as a science base for a couple of years. And we just don't know. It's just some stupid.
That's my point. This is really my point. We can all focus on colonization, but if you don't fix the issue with energy and gravity, everything's pretty much for nil.
Right.
You just would have to accept the fact that you're stuck on Earth, just doing what you can in the environment that we have biologically developed to over the past couple million years. You know what I mean?
Right.
And I think that's where that focus kind of lies. I love the fact that people say, you want to mine stuff. Well, think about the advanced trigonometry to launch a rocket and have it land on the moon or even launch from the moon to another planet is insane. And then you're saying, I want to send robots or satellites out to capture something that is moving through in some sort of, orbital arc, ellipsis, through our solar system and try and mine this object at speed and then bring it back. The difficulties just seem a little insane at that point. And your book adds so much reasonable stuff. And I feel like we just need to continue to focus on the reasonable aspects of this.
Right. We're catching a little bit of that, with these 2 missions that went to asteroids just to scoop up, a tablespoon, just a few grams of material, how challenging that was. Because you got that action reaction thing. There's very little gravity. So you put a digger down and then you push off because, you can't land on it. We talk about mining these asteroids, but it took that much effort and years of effort just to get close, just to get a little scoop to bring back to Earth. That's the beginning of it. It has to get much, much better before we can go on.
And
I like the idea better of towing an asteroid to Earth in between the Earth and the Moon. That's probably more feasible, as difficult that might be. You can put some solar panels on it, and once you give it a push, then you have to stop it before it lands on the Earth, but
Well, I hope you find a small enough, more slower moving one, because if you get that wrong, you just launched a big old bomb towards the Earth.
That's right. That's the concern also, of weaponizing space. You might be able to weaponize asteroids, but they're not very precise. So
no,
it's hard to pinpoint.
But if you can get generally close, if you just nick the planet, you're going to do plenty of carnage.
Right.
So, you had mentioned, and I'd like your take on this. You had mentioned objects like Oumuamua, right? What's sort of your flavor on that? And I've spoken with Avi Loeb. He's come on the Turtlecast to speak about it. What's your take on this sort of archaeological extraterrestrial object is how he would explain it.
Right. No, I heard that podcast. That was great. He's a wonderful individual.
Thank you.
So he doesn't really know me, but he's an astrophysicist. And in my time at NASA, I interacted with him. It was a while ago. But a brilliant individual. Really went out on a limb on this, and he took a lot of heat from people in his field. But that's good. He's speculating, and there's nothing wrong with that. My personal take, it was, so for the background, Oumuamua was that long cylindrical asteroid comet. No one really knows what it was, but it came out of nowhere, passed through our solar system, and went away a few years ago.
Yep.
And it was about a kilometer long, and not half a kilometer long, maybe like 100 kilometers.
It's like an oblong spheroid, something like that.
And the funny thing about it was that it was very reminiscent of the Arthur C. Clarke book, Rendezvous with Rama, where something like that with aliens, hibernating aliens came through. So very, very fascinating. And but to that, I say sometimes, to paraphrase Freud, sometimes a cigar-shaped rock is just a cigar-shaped rock. And so, but that concept is fascinating, and I think that's what Avi is really pointing to. And when you think about that, that is like a perfect interstellar space vehicle. If we could have hopped onto that, hundreds of years from now, and get inside it and build a rotating habitat inside there where we would have our artificial gravity. And if we could have the fusion thing down by then, we would have all this water ice. We could isolate the hydrogen and have fusion energy. We could ride that asteroid. That would be the comet, the structure of the asteroid, whatever you want to call it, that provides incredible protection from cosmic radiation. And with a little bit of a push, as that's coming through, you could whip around the sun, and with a little bit of push with fusion energy, you could accelerate that to 10% the speed of light. That means you could get to Alpha Centauri in 40 years. It's 4 light years away. So it could get there in like 40 years at 10% the speed of light. That's what's fascinating about that concept. Now, was anything living in there? That's where I would, disagree with Avi. I do believe there could be intelligent life in the universe, but for it to be humanoid or for it to want the kinds of things we want, the sense of adventure, I think that's asking too much.
Interesting.
The universe is so big, and all we tap into is this 10% that's ordinary matter. And we view things in this little strip of, electromagnetic radiation that's visible. That's our little world of the universe. And if you're evolving someplace else, maybe you're evolved to take in dark matter. Maybe you can see or possess dark matter or tap into dark energy. We don't know that, but they would have evolved. I think evolution would be universal, and they would have evolved utterly different, and it would be beyond our comprehension.
I love what you just said, and I want you to go a little deeper on that. What do you mean by evolution is universal?
Well, things happen. It's not, people think about evolution in terms of life on Earth, and that, of course, that's what it's mostly applied to. But as I started this talk, I was the senior writer for the structure and evolution of the universe, and you had a big bang. And and later this year, we're going to launch the James Webb Space Telescope, and then maybe in another year, we'll be able to see the very early universe when stars and galaxies were first forming. But that obviously took some time. It was an evolution of just dust and stuff, and just hydrogen and helium and electrons, and eventually, they evolved into atoms. And then they evolved into they formed clouds. They evolved into clouds, and they evolved into stars. And then physics took over, and there was nuclear energy that takes place. And the stars burned, and then they exploded and released the fuel, the ash from those stars, the carbon, and all these heavier elements. And they went out, and they started evolving into other things. They started to get together to form complex molecules of water, so-called complex, and carbon dioxide and oxygen, and all these things we depend on. This is an evolution that took, billions of years before the sun came around, about 4 billion years ago. And then, it's just a long process. So it's happening all across this massive universe that's 96 billion light years across. And the same mechanism that's making things change and evolve on Earth is taking place every inch of this universe in ways that are defined by that local environment of heat and water and all these types of elements.
And regardless of where it is, and not to deal with like relativity too much, but if you think about the aspects of our viewpoint as the viewer, it takes a long time for light to get to us, correct?
That's right.
So for you to say that nothing else has evolved as us becomes a very ignorant statement. And I'm not saying you, but individuals saying that, because if you view things from your perspective, you're capturing it a long time later. So these things could be far, far, far developed, far beyond what we are, still taking that natural path of evolution that evolution takes. You just can't see where it is depending on your relative view as an observer, right? In space. So if you launch a telescope, it's all well and good, but you're staring at the past. So unless you actually move with this specific thing as it develops in that local time-space vector, or space-time vector, that's when you start to see, evolution really occur. And what my hope is that we continue to still have our focus here on Earth, on our space-time, time-space vector, whatever it might be, for dealing with our own evolution of understanding each other and understanding the planet, because we're on a very good trajectory of burning ourselves out. And you did talk about this, and I want to bring this up, and that's the issues with climate change. Now, I understand that we sit on the outer rim of what we would call our Milky Way galaxy. Now, our solar system is translational movement, right? It's spinning and moving in a direction, but we've moved closer to a galactic center. So there's an increase, slight, very slight increase in that cosmic radiation which we receive from the galactic center of our galaxy. That has increased the brightness of our planet along with the other ones in our solar system. And through that increase in brightness, we have an increase in temperature. But then when we come in as human beings and exacerbate that with our own internal systems, with our own internal waste, we're causing a problem for ourselves. And I want to have the focus on going out into space, seeing these things, exploring, living longer lives, dealing with new environments, learning more, evolving. But I feel like we're shooting ourselves in the foot because our focus is that we can't solve our own internal issues here, especially solve the issue with us respecting this thing that actually affords us the ability to have life. But we think we can go out and architect closed systems that can sustain us, but we can't even sustain the one that has, developed itself. We haven't learned from it. Like, that's a huge issue for me. So how do you look at that in sense of that logic?
Well, I think the modern environmental movement really got a kickstart with those first images of Earth from space, and just, wow, that's it, isn't it? That's everything. And then we got even deeper, and we saw that Earth was just that little speck when you pull out back towards Pluto, and that's everything. That's all of humanity right there, and that's all we got. And we better start taking care of this. I thought going out into space really changed our perspective of how important Earth is, not what's out there, but what's in here that we have to monitor. So I get this all the time. It seems like whenever I have a lecture or something on YouTube, people comment, why are we going into space? Because it's just a waste of money. We got so many problems here on Earth.
No.
And I say, well, that's just it. Everything we're doing so far in space has helped Earth. I mean, that's what communication satellites are doing. That's what weather satellites are doing. That's why we know we're in the amount of trouble that we're in, because of what we're doing in space. And we have to keep on going into space to better our life on Earth. Tap into that energy you were talking about with the sun. There's never a cloudy day in space. You could be collecting solar energy all the time and beaming it down. You could be putting supercomputers in space where they're much more efficient in the
keep them cool
in the 4 Kelvin of space. They operate far more efficiently. There could be all these things that we're doing in space that would make life incredibly better, and in an ironic way, allow things to be more primitive on Earth. So if we could get it's infinite resources out there, and if we could get those resources out there, then we don't have to go to the Amazon or the Philippines or these other places that we're ripping up, the last places that we can possibly get stuff from. We don't have to keep on ripping that up, and we can allow people to live more primitively, ironically, and more closer to nature. With this space age technology of communications and iPhones and solar panels on your roof and everything's connected, you could live closer to nature than ever before if we can grab the resources, the energy and the materials from space. That's my take on it.
And, I do like that. And here's my rub. Okay. And I want you to help me think through this. Say the oceans by 2100, okay, rise to an unfeasible area, Micronesia, gone, right? Spice Islands, gone, right? Most of our coastal areas, gone. Refugees are forced to go to the Arctic areas. Well, that's just about at the time when we, supposedly would start to colonize a planet. You're kind of like racing to get to space and also racing to kill yourself at the same time. So it's like you have to really put focus into one first, because the timeline for both actually don't work.
Mm-hmm.
From
right.
What NASA is currently projected for where our atmosphere is headed and where you have projected for where you reasonably see us in space around 2100, those timelines actually, it doesn't look beneficial. So how do we have a focus, Chris?
Right. Yeah, I would argue that this idea that we have to get many people off the Earth to save people, to be a so-called multi-planet species, in case all these bad things happen on Earth to save our species. I think that's the wrong logic because that breaks apart in so many ways.
Mm-hmm.
In terms of the global warming, if things become so untenable here, to be on Mars, to live on Mars, a lot of people living on Mars, you would have to create mini Earths on Mars. And if you could create a mini Earth on Mars, if you had that technology, you would do it on Earth to save Earth, right?
And then you wouldn't leave. Yeah, you wouldn't leave. They're like, oh, perfect, great.
Yeah. So the argument is that it's exactly what you alluded to at the beginning of our conversation. The process of going out there is inherent with new technologies that make things that much more efficient, with water purification and with air purification and with new forms of energy efficiencies that reduce the reliance on fossil fuels. That all goes hand in glove with our pursuit of going out into space. So that's why I think it's worthwhile going out into space, because that's the main route for the technology that can help save the Earth and keep more people here. I am pro-life in this regard, that I'd like to see more people on Earth. And I know there's a limited finite amount of space on Earth, but I think we could house many more with better efficiencies. And I think, maybe it's too altruistic, but I think more people mean more ideas, more entrepreneurs, more inventors.
Yep.
Okay. I don't think it means more criminals. But if there's not an expansion of the resources or an expansion of the efficiencies, then it's going to be war over the limited resources that we have. That's why I tried to end the book with this. What is our future? There's two different futures. We stay on Earth and only take care of Earth, and that means a forced reduction in the population and a constant fighting over the limited resources. Because God forbid, if everybody in China wants to start driving, like we do in the United States, they have every right to do that. But where are these resources going to come from? So there's fighting over that. Or you go into space, and instead of every person born on Earth stealing your resources, every person on Earth is contributing to knowledge and the betterment of humanity. That's how I see the future going if we pursue more space activities.
Yeah, Chris, I appreciate deeply the fact that you're reasonable and optimistic, because a lot of times, logic and reason can be met with great pessimism, right? So essentially like a negative outlook for the future. But I like how you have married a bright future with looking at the obvious trajectories we are on right now and how we can reasonably solve that and learn to live a more symbiotic life with not only what we have going on here on Earth, but what we can also learn from the technology with going into space. And I think that, this is a great first step in reason for mankind, right? The thing is now we just got to take the leap.
Yeah, I think things are getting better. When you look at things day by day, it may seem like things are horrible. But when you look at things over the centuries, I think human life expectancy growing, people out of poverty growing. We're now down to, compared to the 1800s when I think it was upwards of 80% people living in absolute poverty, we're down to 10% people living in poverty. And that's mind-blowing achievement that's been enabled by technology of not saying no to these technologies because they don't put food directly on somebody's plate. Why are we doing it if it's not giving that person food? These technologies are just enabling the water purification systems and the irrigations and jobs and, all types of changes that just raise billions of people out of poverty. That's what the progress has been happening over all these years. So that's why I'm optimistic that this continuation of our pursuit of technology can even make things even better, as much as we're fighting at the very moment.
Yeah. And I'm optimistic that in the future there will continue to be more people like you. It won't specifically be you, Chris, but there will be more of you. And the the fact that you have progenitors and you get to teach them that sort of mindset, I think is a really healthy and beneficial evolutive mindset for, humanity going forward. So thank you for doing that.
Thank you.
Yeah. Well, listen, Chris, it's been 50 minutes and I appreciate you coming on, and I'd love to have you back on because there are a lot of other sub points in this book that require a lot more attention and a lot more dialogue. So if you're ever interested, we'd love to have you back.
Excellent. Thanks. It's out in Korean now, believe it or not.
Listen, I got to say, that's amazing. And because it's out in Korea, where is it where people would go to find your book? Where's the best place for them to do so or find out more about you?
Well, it's Harvard University Press, and, bookstores kind of carry it, kind of don't. I've had a 50-50 mix. But it's, Amazon, and I don't want to, I don't work for Amazon, but online, I think a lot of people are buying it. Here's the Korean version. It's called Space Rush. I don't know where that comes from, but it's in.
Listen, I love it though.
Yeah. But yeah, I think.
Yeah, no, that's absolutely fabulous.
Harvard University Press, and it's. I saw it in a bunch of Barnes and Nobles and things like that. Sometimes I go in and surprise the people, and I say, "I'm this guy. You want me to sign the book?" And it's all around Baltimore. I've hit a lot of bookstores where I could sign it.
Well, I think that's fabulous. Well, next time I'm there, I'm going to have you sign my copy because I'd really enjoy that. But for the time being, please keep up the great work. I think this sort of insight, this sort of intellectual challenge is important. And it's one of those things that pushes us forward. Even if it's not a material technology, it's the thought that counts.
Yes, that's a nice point. Yeah. Appreciate your interest.
Thank you again, Chris.
Yeah, thank you.
Thank you for listening to TotalCast with your hosts Alexander McKegg and Jason Rigby, where humanity steps into the future and source data defines the path. What's your data worth?